So let's see. I think I can share the screen, and then we can go through the different points. So we're at the inner circles now. Congratulations for making it this far. Today we discussed the Strax data model, so the way chunks are set up. We're going to talk about plugins, how they work under the hood, except for the really gnarly data flow bits, which we'll talk about next week. And we can talk about the implementation of the different plugin variants. So I propose we start with the chunks. So let's see. We have here the chunk.py. Can everybody see my screen all right? Okay.
Yes.
So any questions on chunking in Strax?
I guess I will start. I don't have questions specifically on sort of the philosophy, sort of the bigger picture behind it. But I was digging through the code and I found a couple of places where it looks like it's some vestigial code, and I want to sort of figure out exactly what the ideas are behind that.
Sure.
So for instance, line 56 and line 57.
Mm-hmm.
You're calling the exact same function with the same input twice, storing them separately, and then checking to make sure that they're equal to each other. Now, there's something very similar to this in plugin.py.
Oh, yeah, this looks bad, right? I expected that God should be, I put in something else here. So one of these should be, what should it be?
So in plugin.py around line 411, there's effectively the same thing, except one we're calling the D type on something that's passed in, and the other we're checking the D type on basically the expected D type that we expect for something with that name. So my guess is that's what it's supposed to be, and then
exactly,
copy pasta ruined originality.
Yeah, no, yeah, good find. So indeed, the deal here is that I want to compare the data types, but I want to remove the titles field first, because if somebody just changes a comment on the data field, I don't want to invalidate all the data. But of course, you need to compare the actual expected to the got data type, and that's not what we do here. So yeah, good catch. Please open an issue, or if you know how to fix it, that would be even better. But this is clearly not correct. This will always pass.
Okay.
So yeah, and you mentioned something about maybe it's copy-pasted code. So yeah, perhaps we can factor this into a function.
It might be tricky to combine those into one sort of more global function. Maybe.
Yeah.
Could work. And then one other, so a couple lines down on line 68. So we're looking at the 68 in chunk.py. So we're looking at the end time of the chunk of data that's coming in. Is the final record, or the final entry in a chunk guaranteed to have the latest end time? Because the chunks, so are the chunks sorted by start time or end time? Why is not the chunks that are the entries in them?
That's a good point. So let's go to the laws of chunking. Let's see, which I wrote when I was completely in the zone for chunks. So yeah, so a data type, so a chunk, when it is a start and an end, and all of the data must fall within that. But you're asking, hey, which of these data types has the last end time? So if you have data that is disjoint, like peaks, events, that is guaranteed to be the last one if you sort it by time. If you have records, then that's not guaranteed. So indeed, this isn't necessarily really the last end time. So if you wanted to check everything, what you could do is just loop through all of the things, or I suppose you could take here Strax end time max, which would do the same thing. Then you really have the last end time. But of course, doing this you would have a bit of a runtime penalty for that, but you would get a better check. You're right. And I suppose this will fail if the data is empty. So, oh no, that's what this already checks. Yeah, so this is probably just a better way of doing it. But there would be a penalty. I don't know how large this would be.
The example I was going to fabricate to see how this works, I realized about 30 seconds ago doesn't work. Just because everything is fixed length.
Mm-hmm.
But so actually no, I think this does work. So because,
yeah, you're right.
Because peaks. So for instance, peaks are it's fixed width in terms of samples, but because of downscaling, you can end up with sort of variable width in time. So if the last peak in a chunk is relatively short, but the one that comes before that is much longer, you can have the second last peak with an end time after the last peak.
Yeah, but the peaks have to be disjoint in Strax, so that could happen just by the data type, but the way we produce them, they are always disjoint. And
that is true.
You make a very good point that what I was saying would apply if you have variable length data, but our data so for records is fixed length. So this does actually work. It does give you the last end time because records always have a fixed length.
You can run into peakless, right? Because then you can have two at the same time, where one was big and started before but ends after the last one, right?
I think even peaklets they have to be disjoint. For hits, you can get it for sure. Hits are not saved at the moment though, so they don't pass through this stage when we make a chunk of hits. Another issue where this would not do the full check is if you have neutron veto and TPC data combined. So if you have one big raw records chunk made, and then because the neutron veto does have a different DT, so I'm guessing we would have to have the same amount of just samples, but they would correspond to a different time, so that then you would hit something here.
Okay. So we might want to make a note. I think Daniel, you opened the issue in Strax on how to deal with the variable DT data field, at least in the DAQ reader. We might want to reference that this line here might also be an issue when we're working with this.
Yeah, good point. So in principle, the line will work. It's just that it won't check everything completely. So it will just assume that this is the last data. So there might be some earlier piece of data that violates the chunking laws, and that will then pass through and create madness later on in the chain.
To be extra sure, couldn't we just look at the last 100 peaks and find the arc marks as you propose to do it for the entire set?
Yeah, we could do that. So that would be this as no. Let's see, like so. Yeah, that would work. Yeah, that's a good compromise. I think this will not crash when there's less than 100 entries, right? Better to check, I guess. If you start Python. Right, so I have this thing. Yeah, that's fine. Okay, good idea. So if you do that, you would of course add a comment here. Though still, then there would be the issue that maybe there are more than 100 entries, and yeah.
I mean, at that point, we're dealing with edge cases on top of edge cases.
Yeah.
Edge case squared.
Yeah, maybe the first thing is just to check what's the penalty for just doing this. Then if that's negligible, then you just do this and you're sure, then there's no question. But if it isn't, then yeah.
The end time function, that's that just checks once to see if the fields exist, and then yeah, just evaluates it. So
Yes,
I'd expect that function to be relatively quick because it's just doing, I guess that's integer multiplication, integer addition. So that should be exceptionally computationally efficient. Even if you're doing it 10,000, 100,000 times, it's just straight integer mathematics, and so that should be very quick.
Yes. Yeah, you're right. This is actually a bit of a funny function. It's this NumPy generated JIT. What that means is that so this check is evaluated at compile time. So when we pass something, which is runtime, so that's a bit. So there's a just in time compile time. When you pass something, then the check will be evaluated, and you get one of these functions back, which is NumPy optimized. So yeah, this should be okay. I don't know how long this just in time compiling check, how long that takes. If you're inside the NumPy function, then it should get optimized and there's no problem. But in this case, you're calling it from just the regular Python layer, so there might be some wizardry there going on. But if there is, then that wouldn't matter if you do just -1 or not. So yeah, you are right. The check is just going through the data once, basically, and doing an addition. Okay. Other questions or comments on the chunking, the data model?
I have one general question. What's the deal with integers? Why do we keep converting all the times and everything to, I think you commented, like bona fide Python integers?
Yeah, so let's see, where do we do that here? Here, for example. Yeah, here, that's right. Let's see, so NumPy has specific integer types. So there's NumPy in 32, in 64, and when sometimes you can do some kind of check and then it doesn't equal that if it is one of those funny integer types, or when you use them in slicing an array, I'm not sure that will always work. So this is just a bit of insurance to convert it to a regular Python integer so that later on I can use it without having to worry about something going wrong if it's a NumPy data type.
Okay, so it's not a speed thing. They would ultimately, like, if you didn't do that, it would take the same amount of time. It's just purely for the sake of comparison of the numbers.
Yeah, I have no idea on relative performance, but I would guess there's no difference. Yeah, it's just for safety that you don't get into. I've been burned by this several times when these NumPy things, you try to convert something to JSON and then, I don't know how to convert 3 to a JSON because it's not the usual 3. So that's
right. Okay, makes sense.
Sure.
Another question.
Sure.
So down at the end of this file, we have the split array routine, which we use mainly for splitting chunks.
Yeah.
A lot of this specific function does look very similar in scope to the which is this? It's the split or fine split that we're doing in the DAQ reader.
Mm-hmm.
And
so that's the fine break something.
Yes, clean break.
Safe break.
Safe break, that's it.
Yeah. From break here. Yeah.
And it seems like that there's a lot of overlap in what these functions are doing.
Mm-hmm. Yeah, so this looks for a safe break in the data, and it just splits it at the first safe break. And this guy, it starts at a specific time and then scans, if I'm right, the other way to see if you do this allow early split to find the first break. So yeah, there's definitely overlap here, except that the scan direction is, I guess, different. But yeah, perhaps there's a way to combine that, and then we only have to have one of them. I suppose they look like they're both tested, so that's good. At least split array is tested. And this test split array. Let's check the other one. where is it? Find break index, part of from break. Yeah, that's also tested. So that's great. Then you could try to modify them to have one call the other, see if the tests still pass, and then, or make a generic function that does both things. But since they're both tested, they should both be correct, unless we haven't hit the edge case with the random input generator yet.
I was just thinking more from, I guess maybe a high level standpoint. You know, if at some point we find a better algorithm to do this, I see it highly likely that we remember to update one and not the other. Whereas if they're fundamentally calling the same function, you know, you find a better algorithm to do this, then I mean, you update one of them and then they both benefit.
Yeah, I see what you mean. There's a kind of conceptual similarity, maybe, that there's a notion of what is a safe break. That is slightly different between these functions. So in the DAQ, a safe, or the DAQ reader, a safe break is defined basically with reference to what the peak finder is going to do. That a safe break is large enough that you won't have a peak spanning it. So you'll know that all the peaks can be found in the same chunk, so that you can pass the chunk to a CPU and you can do the peak finding there. You don't have to do that in overlap window plugin. Here, all you want is that there's no overlap. So you can't split at an overlap point, but it's completely fine to split at a 10 nanosecond gap. You can split the chunk like that. So yeah, there is a bit of a difference, but and you can have situations where you update one and not the other. I don't see a situation for updating this one, but or at least letting it do something completely different. But the DAQ one you would update if the peak finding becomes really different. But yeah, we can still look at finding some common function that would, of course, make things simpler and more robust in general. I very much support that.
I have a conceptual question on the difference between the merge and concatenate functions.
Sure.
Like, I guess I couldn't figure out why they couldn't just be one function. Is it because one is on the doing something to chunks and one is doing something to an array?
So they're kind of different operations. The concatenate, you take something of the same data type and just put it after it. So that's sort of adding extra, I suppose they're called rows, even though I have my hands horizontally, but yeah, so you make the array longer, whereas with merge, you actually change the columns. So you make a different data kind. No, sorry, because data kind means something. You take data types of the same kind, so like peaks and peak classification, peaklet classification, I guess it's called in peaklets. Then you make a new NumPy data type, which would encompass both columns, and you fill in the data from that same thing. So it's a different operation. Yeah.
So when you're sorting by time, and you would take the two types of like data types or kinds or whatever and match them up by time, and then the other one you'd match up by, I guess, whatever the columns are. So they'd all be different times, all of the things. So maybe that doesn't make sense, but I think I get it.
Yeah, so in concatenate, you have the same data type, so you don't need to have to do any sorting. You concatenate them, but they should still be sorted because chunks should be sorted. And I guess there's a check maybe.
There's a check. Yeah.
Yeah, that should be, yeah, here, out of order chunks. So you just pass, you just put them next to each other. And here you're making a completely new NumPy data type. And the columns, the rows have to be exactly the same. You have to have 1,000 of this, 1,000 of that, 1,000 of the third thing.
Got it. Okay.
Yeah, perhaps an easier way to explain what's happening with these two. In concatenate, you're taking, you know, if we think of data in flat tables, which is kind of how it's all represented, in concatenate, you're adding extra rows onto the bottom or the top, depending on the time ordering. And in merge, you're adding extra columns.
Yeah, that's exactly it.
Gotcha. Yeah, that makes sense now. Thanks. So I guess this just kind of proves the whole thing that Strax is built on time sorting, right? Like it's pretty much the heart and soul of everything in Strax. Yeah,
it's an assumption that permeates all throughout the code. That if you have non-sorted data, then yeah, this whole business of doing stream processing doesn't work. If you have data and then at some point you said, oh, wait a minute, 10 minutes ago, you should have had it this. Yeah, that's too late because we already wrote out that data. That's some of the problems that Jason encountered when he was merging different Monte Carlo sources, which have these really long delays.
Cool, thanks.
Okay, more questions on the chunks, the data model.
I have a question. Oh, sorry.
Sure.
No, right now I'm trying to do something. Basically, select the data for us, for example, a single PMT.
Mm-hmm.
So I want to select the channel for a single PMT and create a new data set with all the, for example, the area relate to this channel.
Yeah,
I can
sure.
use one of these create, merge and concatenate to do that.
So if you somehow ended up with a Strax chunk, then you can extract the array with .data, and then you can get you can apply any usual NumPy operations like you did with just with data frames or so another. But it should be fairly unusual that you end up with a Strax chunk. You usually just get an array. So if you just do get array from the context, you will already have an array, and then you can slice it however you want.
Sorry,
or you can even pass a pre-selection string, for example, channel equals 14, and you only get the data from that channel.
Yeah. So if I want to, because for each chunk, he create a single array, and then the final array is a collection of array, the final result, no? For each chunk, I have a collection. So my idea is to make a single array for this. There is some function where I can merge all these array together. It is more Python question.
Okay, so let me just see if I get it correctly. So you you said that the final result is a concatenation of the many arrays. That's right. So if you do get array, what happens is that Strax will loop over all the chunks, get the arrays from each, and just concatenate together and give them to you. So normally you don't have to worry about the whole chunk business. But when you're in a certain loop with get iter, for example, then you do get different chunks.
Yeah.
And I understand that you're trying to do something like that. Is that right?
Exactly, yes.
Yeah. Yes, so in that case, you do .data to get the data out, and you do a selection based on that. That's right. Yeah. Okay. So you don't need to use any of the just like split or concatenate, merge. You just need to select certain specific pieces of data in the data of the chunk.
Okay.
But get iter also has an option to pass a selection string, if I understand correctly. Let me see, maybe I'm incorrect. Get iter here. So get iter also has a selection string. So if you pass here channel equals 14, then when it's looping, we haven't talked about get iter yet. We'll get to that, I think, next week. But mainly it's just a for loop over chunks. And part of this is this apply selection function, which is horribly formatted. It's just like this, which applies to selection, and you can do keep columns, time range, and everything else you do with get array. So you don't usually have to do that, but of course you can. There's no problem if you want to do that.
Okay, yeah, no, because I try to find a way to work with the single PMT more quickly with the iter, for example. This is a good way, I think.
Yeah. So definitely check then the. Let's see, I think the first Straxferno session where we went through different ways of reducing the data so it can fit into memory. And we also covered the accumulate function, which might speed up your analysis here.
Okay.
Okay. Right. So more questions on the chunks and the data model.
Yeah, so
Sure.
if I get this correctly, the chunks is just it's just your partitioning of the data for processing, so you don't have to process the entire let's say run at a time, right?
Exactly. Yeah.
So what would happen if you split arrays on start time instead of looking for the end time that's where there's no overlap?
So you're saying when you need to split chunks, which does happen when you have, for example, you load a minute chunk and a second chunk for another data type, then you need to split the minute chunk in order to get, or you need to get a lot more of the second chunks. What if that was not done very nicely with just idle start time? What would happen then is you would break one of these laws. So you could have a chunk with data that extends beyond its end time.
Right. Yeah, I'm asking about the reasoning of the law.
So the reason for that is that it's just something that a plugin can assume. So you have, for example, a peak finder. It needs to know that it has all the data between two times for it to know at what range is still safe to make peaks. Or when you have a trigger algorithm, that you have all of the data between two times all of the peaks there, so you know that you can decide whether there's a trigger or not. And if you don't have that guarantee, you say like, you get a guarantee like, yeah, you have all the data here and then maybe some of the data over here, then it gets difficult to process that. So the overlap window plugin helps you a little bit with that, but that can only operate, or at least operate easily with this law in place. But it's certainly possible to write Strax in a way that doesn't have this law, because we didn't used to have that law. This is a new addition. It used to be the case that arrays were just passed along, and you hoped basically that the chunking was okay. It was good at the beginning when we had the DAQ reader and needed the split, but then when you loaded it back in from disk, it could be anything. But then you open yourself up to some nasty edge cases where you load like part of a thing, but you think you have all something like that.
Okay, that makes sense. Yeah, so there's no. I'm just wondering if there's a maximum duration defined for these peaklets, etc., where in the processing when they're created.
That's a good question. So for records, we know that things have a fixed sample length. Their DT could be, well, for the moment it's fixed, but once we include the neutron veto, there will be one other possibility. But for peaks, the DT can really be quite long. I think there might be a maximum option. Let me just check. Maybe we removed it. So peaklet processing, peaklets, we have here find peaks. So if there was a maximum option, it would be here. No, I don't see it. You could implement it. You could add here some kind of maximum option that if your peak runs over a certain thing, you will just bluntly terminate it and do that if that helps with the chunking. But it looks like they can be as long as the entire chunk of records that they come from. Of course, they have to end at the end of the chunk because the chunks are separated by the DAQ reader to obey this, have a separation larger than this gap threshold. So you know a peak ends at the end of the chunk. You don't know anything else at the moment, I think.
So there's no limit on the size of a chunk, basically, that means, right? Because the DAQ will just keep a chunk going as long as, or is that coming maybe from some high energy, like is there a veto somewhere that's cutting it if it's extending too long?
So the chunk length, at least, there's two concepts here. There's the chunk length that's really made by the DAQ, so made by Darrell's software Redux. That is very specific, but those chunk, which is configurable at the beginning, but those don't obey the laws of chunking because they're just based on raw time, because the digitizers don't want to communicate constantly with each other like, hey, have you still got something that do I need to extend the chunk? You just output it. But then in the DAQ reader, we we read the chunk, and the little chunk before and after it, there's like split up into a large chunk, small chunk, large chunk. And then we find a split point that is consistent with the laws of chunking, and it does obey this gap threshold. And if there isn't one, we will artificially add that time to the data and clearly mark that as such so that it does obey this. I don't think that currently happens in data, but so you always know that chunks are separated by a certain gap threshold that is configured for us. And chunks cannot have a length that is longer than the size of one large chunk plus the size of one small chunk in the DAQ reader. Let's check what the defaults are. I mean, these defaults don't really matter. It's the defaults that the DAQ passes, but I think we want to check that they were consistent. So that's 5.5 seconds. That would be the maximum chunk length for the low-level data types. For the high-level data types, the chunk can be as long as the entire run if you're reading it from disk.
Yeah. So theoretically, so I'm guaranteed that the chunk will never be longer than the whatever the setting is for these settings, right? For the sum of these two numbers.
For low level, so for records and raw records, you have that guarantee because we specify in the plugins that operate on them. So for example here, pulse processing, you can't read chunk on save. So for other plugins, what happens if there's like for peaklet classification, the chunks are tiny and computing gets mad at us if we make too many small files. So we chunk them together into one big chunk. But for pulse processing, we say you can't do that. Because if you rechunk at a random point, this guarantee of the 300 nanosecond or whatever the gap threshold is not necessarily obeyed.
Yeah, okay, but the resaving won't affect the original division of the peaklets or whatever the low-level data is, right? I'm just trying to think if there's I really like, so if I can find a way to reduce the complexity and the splitting of the chunks, it's really annoying.
Yeah, no, I agree. It's a hairy part. So I think the way we implement these rechunking is such that it won't split just somewhere randomly in the middle, because that would again violate this this thing. So it will just like add maybe say 2 chunks or 4 chunks. It won't save like 3.5 chunks to disk, but we can check. That's in the file saver. I think maybe it's in the common routine. So rechunk. Yeah, so what it's doing is it's concatenating. So I'm now in the common saver routines, the one we covered in the last circle. So when you're saving, if we're rechunking, then I'm going to loop over chunks that I'm getting, if I understand this correctly, and just concatenate until I have exceeded a certain bytes, which is beautifully hard-coded as 100 megabytes.
But the event, so the rows here, right? Each row cannot extend beyond the original chunk size, right? Like a peaklet can't extend beyond the original chunk size.
Absolutely,
right?
that's even guaranteed by the laws of chunking in Strax. So you cannot even create such a data type. That would violate the check that we started with today. Right, so this stuff over here, it would say, hey, it doesn't work.
But I guess if we added if the overlap window was that large to accommodate such an extreme case, I guess it would be very inefficient. So, okay, I'm just thinking out loud.
Sure. Yeah, so suppose you have a case where a peak gets really long. Yeah, then the DAQ reader would at some point terminate it, right? If you have some PMTs, like 5 PMTs just constantly making a signal, then if it lasts longer than a couple of seconds, at some point, we'll have to insert this artificial dead time to enable Strax to break it, and then you won't get a peaklet that's longer than that.
So if I conclude from what I understand is, just to make sure I understand. So theoretically, it would be possible to do this like cutting on start time of each peaklet / whatever low level rows, and just have the overlap window plugins make sure the overlap is large enough to accommodate the largest one. But the largest one can be a few seconds, so that would be completely inefficient running the overlap windows with an overlap of a few seconds, right?
So yeah, you're saying, can we relax this law that it must contain only all data that ends between them, because that would allow you to split chunks and split and merge chunks in an easier way. I suppose you're right. There would be a way of doing it, but yeah, that would require some changes and some checks that, since the guarantee no longer holds, but it would be replaced by something else. It's now you fall back on whatever the DAQ reader did. That ensures that there's some separation. Yeah, so that's something that we could look at. I kind of like this law though, the fact that you just have a chunk that it is always all and only all data that's between 2 times. That makes a lot of things simpler, like the code for selecting data in particular time ranges, which actually still has a bug. But that code used to be usually complicated with edge cases, and it's a lot simpler due to this.
Speaking of bugs, in 3A that you have it there, you say the end time, now this is in the laws of chunking.
Okay, yeah.
In 3A, you say it has to end less than or equal to T1, but then above and directly below that, you talk about half open intervals.
Yes. So I think
it should be end strictly less than, because if it ends equal to T1, then it should be a closed interval.
Well, if it ends at 3 seconds exactly, then the end time is 3. And yeah, so what exactly does that mean? So that means that that sample that starts at 3 is no longer included. But you would allow this into this chunk, because the sample that is at T1 is not included. So if the end time is exactly equal to the right end of the half open interval, because the data is also a half open interval, it is allowed to be equal to that.
So 2 half open intervals make a closed interval, because the data itself is half open. So we're kind of applying this half open check in sort of 2 independent ways, I guess. It's just like, so if looking at what's written here, I'm just trying to see like if it's potentially unclear for someone that doesn't have a particularly deep understanding of exactly what's going on.
Yeah, so perhaps there's an ambiguity here with ends. So what I mean here is that the exclusive end, so that the last sample to the first sample that is not included in the interval, because that's what it means for these half open intervals, that can be equal to this T1 over here. So because the data, so that the records, peaks, and so on, are also half open intervals, they are allowed to end at this same point, with the understanding that that is an exclusive end, not an inclusive one. Yeah, that's. But yeah, if you have a suggestion to reformulate that, happy to receive that.
I guess the half open interval rule applies to the T start, right? So it's guaranteed that it starts at a time before T1 and not at T1, right?
Yes, because the start time is inclusive. Right. So if it starts, yeah, that's part B.
So you can add to the starts, you can add a half open interval condition, and then at the end, so you separate the conditions maybe between the start time and the end time, and then it'll be clear maybe. I can, yeah.
Yes,
because I understand where it's confusing, because it's like you have 2 times here, the start and the end, and the rule applies differently to each, right?
Mm-hmm. Yeah. So if it starts at T1, then it's outside according to 3B. But Yeah. So instead of splitting it by what's in, what's out, you could split. So what are the conditions on start time? Namely, it can be greater than or equal than t0 and less than t1, and on end time, which is greater than t0, otherwise it wouldn't be any sample included, and less than or equal to t1. Yeah. Okay, more questions on chunking and data model. We're going quite deep into this, but that's good. All right. Then let's look into the plugin class. So we're going to look at how this plugin class is made, except for the exact data flow stuff, which we'll get into next week, and into the plugin variants. Let's start with the let's go to the plugin file. Okay. Right. Any questions on plugins, how they're made, different methods they have, different variants?
First question could be, to make a new plugin, there is a kind of template shape version to do, and then you add what you want?
Yes, so if you're asking, suppose I'm an analyst and I want to make a plugin, yes, there are several things you can take as a template. So those are ones from Straxon. So you can look at, so suppose you want to make a high-level plugin. There's a variety of ones here. The corrected areas is not too difficult. That's just a basic plugin. If you have a more loop plugin-like thing, so that just loops over all the peaks in the events, for instance, you could look at, what's it, event basics, maybe? It's a slightly complicated plugin. And in the Strax tutorial, there's also an example plugin all the way at the end. So that you can use as an analyst if you want to look at that. I can also interpret your question, but I think this is not the one you asked, but feel free to correct me, as how does Strax make a plugin? How does this initialization process work?
Yes, there is some formal basic function must be contained in the plugin as initialization process point.
Yeah, so for that, I would take one of the existing plugins as a template. The basic things that you need to define, what is the sort of the minimal plugin that you could make? You'd have to define some kind of data type.
I think the easiest ones are in the cuts because they're really, really easy.
Okay, that's a good point. Let's look at that. Subtraction plugins. Why don't I have the cuts?
It's the Xeno one
yeah.
cut all the way at the bottom.
Yeah, these are great. Oh, for this plugin, it says that you need to contact me with an old email address. Anyway, this is just ported from Lex. Yeah, so right, these are great. So you need to define some kind of dependency. Provides is actually optional, but in these cases you should do it because otherwise it will make it from the capitalization of your class name, which in this case would mean it's S2_threshold. You have to define some data type, and it has to include the time fields, otherwise Strax won't grok it. Version number is optional. If you don't give it, it'll be version 0. And yeah, you should provide some compute method, otherwise it doesn't do anything. So that's the minimal pieces that you need to make a plugin. Thanks, Johan.
Yeah, thank you. This just to have a quick idea of the structure of a plugin.
Sure. Okay. More questions on plugins and how they work on the inside and their variants.
One thing I noticed while I was digging through this, line 212, this is dependencies by kind. the docstring is out of date. It's referencing require time, which I guess was a parameter that we had in the past and then axed.
Yeah, exactly. So this was part of this was before I did the refactor that introduced this chunk class. This was part of like these logics that we needed in order to enable time range selection. So if you wanted to select a time range, you needed to have a variable that included time information. But now all the data types have to include time information, or they don't even pass muster as a Strax data type. So this is no longer needed. Yeah, you're right. So we can remove that. So in these cases, just please make a pull request to just remove it. Then we'll go through it and we can approve it quickly. So it should be no problem. Okay, so iter we'll look at next time. I suppose fetch chunk is part of iter. Clean up. All right, so we do compute, which calls compute.
So compute is a mandatory name of a function inside the plugin.
Absolutely. If you don't have compute, nothing's happening. The only difference is if you have a loop plugin, then so let's go to that one. Loop plugin. So in that case, compute is provided by you, but you have to provide the thing that it's calling, which is compute loop. So that's looping over, that's called in a loop over base, whatever base is, and usually that's events, and you want to look at different peaks. So then you don't implement compute, you implement compute loop.
Okay.
If you don't, you get this nice and friendly error. So maybe one small remark now that we're on this loop plugin. This kind of code where we're splitting things into, so we're grouping things into a list of things contained in the base things. This we can probably speed up. So we do call split by containment, which is good, but perhaps we can make the whole thing here into a numba function. Maybe we have to use numba's typed list, which is a data type was added at some point, so numba can deal with variable length things. And this is a relevant part of the runtime for these higher level plugins. That might be a nice thing you could look into if you want to make Strax faster for high level reprocessing. For low level reprocessing, it doesn't matter at all. Of course, you have the much more expensive operations at the beginning, and also various operations that are just done in the plugin, like calling a neural net. That's really inefficient if you do it with tiny batches of 10 things at a time. Very much more efficient if you do it with large batches. But for if you just want to reprocess and change like a correction or something like this, and there's a loop plugin involved, then this is likely the limiting factor in terms of speed. So anybody looking for a nice project to optimize, try and factor this into a numba function. That will make people's life later easier, or at least faster. Okay, more questions on plugins, like the overlap window plugin, loop plugin, all these kind of things. I hope this docstring is still accurate, but I've written it a long time ago, so. Right, so you can still, it's referencing, you must read time info for your data kind. Well, but of course, every thing contains time info. So this, I don't know if this is still accurate.
I mean, it does say that the inputs are sorted by end time.
Yeah.
Which I think is not true.
Yes.
It's sorting by start time.
Definitely. So what this assumes is that they're disjoint. But I don't think that it really makes that assumption anymore. At least it just calls these like concatenate and split methods, which also work on non-disjoint data types like records. But I've never tested it with records. We don't really need it.
So if no one else has a question, I want to go slightly off script.
Sure.
So the parallel source plugin, which we were recommended not to read.
Indeed.
There's the amount of stuff that's going on in this plugin. I'm still not entirely sure exactly what it's doing in inline plugins. It's extensive.
It is. So this is actually part of the. No, it's not even part of that. But if it were part of any circle, it would be part of, I think, the ninth circle. So it has something to do with how things are parallelized, but you don't really need to know a lot about the mailboxes to understand this. So we can discuss it. What's basically happening here is you want to parallelize processing over many CPUs, definitely at the event builder at the DAQ. So the default mechanism which is implemented in Strax is that whenever a plugin calls compute, you can see this in do compute. Maybe it's not here. No, it's in, then it has to be there. Okay, which we also didn't read, but we'll get to that next week then. But at some point there should be, here we go. So normally you just call do compute, but if there's an executor in play, that can be a process pool or a thread pool, and that has to do with how the multiprocessing is initialized. What happens instead of calling compute, you make something called a future, which goes onto a pool, which, you know, there are child processes that can pull off this work and push the result back. So that is the way multiprocessing is done usually. So this can be a process pool executor, you have a pool of processes that can pull off work. All right. Point is, this happens at the per plugin level. So every plugin can outsource sort of its computation to a pool of workers. But that would mean that, okay, the DAQ reader has that. So DAQ reader has this one computation where you only do the DAQ reader. And then pulse processing would have the same thing. And that could then go to a completely different process. So the data that is a result of these computations would have to transit from one CPU to another CPU. So it will move through memory, and yeah, depending on how the memory is organized, this can cause some slowdowns. And memory could be like allocated to a particular CPU or something. And this goes into CPU and memory architecture I know little about. All I do know is that if you split up a task in many tiny bits that each have high throughput, it's better not to do that. It's better to sort of collect everything into one task. You have one task, you have a chunk of data, and you do first DQ reader, then pulse processing, then peak processing, etc., as much as possible in one task on one CPU. The way that's implemented in Strax is when you start a multiprocessing, it will see, hey, is there some root of this computation? There's generally only one, but in principle there could be multiple if we would have gone for some setup with multiple DQ readers, where I can start and just take a couple of plugins that follow from this graph. Let me, so the graph I have in mind here is just the standard dependency tree. See while it's loading. But I think you know what I mean, right? There's raw records at the bottom, then records, peaks, etc. So you're on this graph, and it's going to look which plugins can I group together into one sort of mega plugin, right? So you start over here, and it's going to scan ahead in the graph and say, hey, I'm here. Can I sort of? It's kind of inlining of the computation. So you sort of create one big plugin that does the compute of this one and this one and this one and this one, and here you hit a snag because this is an overlap window plugin which keeps state, so you can't push that to many different cores at once. So all of this will get into one big Leviathan plugin. That's what the parallel source plugin does. So in inline plugins, what it's doing, you give it a components dictionary, which we will talk about, but it contains just the different plugins, savers, and loaders that you're working with. It will scan through that and see, hey, is this a plugin I can inline? Well, it says it's parallelizable, and I've already inlined all of its sub plugins. So yeah, I'm going to inline that. Let's delete it from the main dictionary. Then I'm going to look at let's see. So what kind of outputs do I need to send from this Leviathan plugin? Well, it depends on what plugins I've just gobbled up. But perhaps an output is not requested by anything else. So then that makes things simpler again. And finally, I'll look into, are there any saving operations I can inline, right? So each of these plugins produces some stream of stuff. The saving operation also takes some CPU, and it's definitely a high throughput operation because it does compression. It would be great if I can also inline that. Usually you can, but you can't if you have this rechunking on. So for peaklet classification, right, computing will get mad at us if we produce one file per DAQ chunk. So you cannot inline that computation because that computation will take a couple of chunks and wait for it to push the disk and then do that. So that's basically what happened here. So you say, okay, can we rechunk this saver? Sometimes there are different ways why you cannot inline it. For example, maybe the plugin says that you can, but the particular saver implementation says, yeah, that's nice, but I cannot be forked. If you fork me, then something bad happens. Maybe that's in the Mongo saver, for instance. That's basically it. And then you construct this Leviathan plugin to do that. That's parallel source plugin. It's not a pretty piece of code, but it works.
So follow-up question, maybe this one's
Sure.
Intended more for Joran. Why doesn't the DAQ reader use this?
Doesn't the DAQ reader use this?
Last time I checked, which was a couple of minutes ago, DAQ reader is Strax.plugin.
Yeah, that's fine. And so what happens is this parallel source plugin, it used to be that you had to subclass it, but that was changed. I hope it was changed. It has to be changed. So let's see, that should be in the processor setup. Parallel source. There it was. Right, so what happens if, so here this is again code we will look into in a few weeks, but if you are in the case that you are multiprocessing and you have several plugins to go, and there is a clear start point, then we're going to make a new parallel source plugin to do this. So we call this class method here, and it will, at some point, it should create an instance of itself. Here we go. Yeah, so you don't have to subclass this. It will be created.
Okay, because I remember, quite some versions ago, the earlier versions of the DAQ reader were subclassed from parallel source plugin.
Yeah, you're right. Yeah.
And so I was really confused. I didn't know that it had been sort of pushed to the deeper into the guts of Strax.
Yeah, so the reason we did that is because if you do reprocessing from records, you also want to use this mechanism. But you don't want to have like everything subclassing parallel source plugin just because sometimes you want to use this particular way of processing it.
It makes perfect sense.
Yeah. So what you have here in the DAQ reader, there's parallel equals process, and that's what triggers this whole circus of parallel source plugins. So if you were to change this to true, then it would no longer use it, because that would mean that you can only parallelize it using threads.
Okay. So for everyone else that didn't follow that discussion, make sure you don't put parallel equals process unless you know what you're doing. I think that's the takeaway.
Yeah, you can put it. I mean, if the process doesn't keep state, you can put it, but it will just usually result in it might result in some slower case. but yeah, just put parallel equals true if you're making a high-level plugin. Multi-threading is fine for most things.
So at which point should I transit from processing to from I think multi-coring to multi-threading?
So if your process, let's see, so it doesn't matter for like the first online processing. So for example, if you look at, let's say peaklet processing, this still has parallel equals process. Okay, then let's go to, what's the next stage? Peaklet classification. Right, so here we have already parallel equals true. This will still be included in the parallel source plugin because you can parallelize it, and the other plugin wants to start this whole parallel source plugin business, so you can include this one. But if you started from this peaklet classification, then yeah, there isn't really a point doing that. So then that's why I didn't do that. But I didn't go through all the plugins and test performance while you start at a different part. My rough guide would be, if it's reasonably likely that you will start a reprocessing at that plugin and the parallelization is then important, then yeah, put parallel equals process. I guess I should add that it's not just parallelization is important, but that it's so high throughput that with the multi-threading, or it's stuck on the global interpreter log or something, that multi-threading won't get you all the benefits. Ultimately, it's an empirical question.
I always understood it like whenever you have to do some heavy lifting tasks, so like whenever you have to include records or raw records, then it's better to use process, while in the other cases it might be better to use parallel. Is this kind of a good rule of thumb? Because this is what I tried with the Envito plugins.
Yeah, sounds good. The only, of course, if you have even if you're working with records, but if you can't be parallelized because, for example, you're counting the records or assigning them a unique number, then you must have parallel equals false. But, yeah. Okay, that was a little preview of some of the things that are ahead of you if you go deeper into Straxferno. I think parallel source plugin wasn't even on the planned reading list, but we can talk about it again in the later circles if you want. It's really only relevant for the like online processing on a many core machine. For processing on one core, which is what will always happen. Also for reprocessing, it won't get used.
I think maybe this is the tales of things to come. You know, in the inner circles, everything is very strongly interconnected.
Yeah. Yeah.
And I expect us to getting off track into other things that take me to a different circle. I expect that to continue until the end.
Mm-hmm. Yeah, that's quite likely. You're right. Okay, so let's try to get back to plugins. Anybody has another question on not the parallel source plugin, maybe, but well, if you do have it, you're welcome to ask. But just on the basic, the main plugins, let's call them.
I have a quick question, probably a quick answer. Why is run ID part of the, like a property and not a in the config of the plugin? Is that just random, or like what's the extra importance of run ID?
Right, so let's see, there's the run ID. See where exactly do we reference it. So it can even be the version can even depend on the run ID. So you can have a plugin that says I'm this version with this run ID and this version another run ID. So that also captures, I think, why it is like this, because configurations can include a run ID dependence. So for example, if I look at where would this be in event processing, I think. There will be default by run here. So here, for example, the field distortion and the way that's currently implemented is that depending on which run ID you pass, at least in Xenon Wonton, you load a different file. So that's why the run ID, it matters for which settings you're going to see as a default. I should say that all of this is potential to change because Aaron is working on a new correction management system. And we're discussing with computing whether something like this is at all feasible, because what this means is that, hey, if the setting that you use changes run by run, that means the hash of the data type changes run by run. That means there's several hashes you need to keep track of, and that gives computing extra headaches. So of course we'd like to avoid that.
I guess I was going to, so having a version that potentially depends on the run ID, I'm surprised that computing isn't already at the door with, you know, pitchforks and torches.
Yeah. Yeah, it's probably because this isn't used at all. At one point, I thought this might be an interesting way of getting some kind of reproducibility for later results. That if you have, I don't really know. I just built it in. It isn't used. Maybe we should keep it that way.
You know, but someone could, you know, if they subclass a plugin, they could implement this function because I don't know why, but they could. And then next thing you know, computing is outside with, you know, pitchforks, and then we're all wondering how exactly we got here.
Yeah, that's right. There's several ropes we can hang ourselves with here.
I still don't understand why that means it needs to be a property and not a config, because they're set at the same time, right? The context sets the run ID and sets the config at the same time. So if you have the run ID, you also have the config.
Let's see. So you're asking why isn't the run ID in the config options of the plugin?
Yeah, and checked and everything the same as the rest of the configuration.
So that's a kind of extreme version of having this version depend on the run ID, because the config determines the hash that comes out. So if you have the run ID part of the hash, then every hash will be different.
Yeah.
You could do that.
That makes a lot of sense. Right.
Yeah. Okay. More questions on plugins? You see more heralds of things to come, like max messages. Let's not get into that just yet.
I guess seeing as you scrolled past it, so the default compressor is Blosk. So does everyone that knows when this fails, so does everyone that works on plugins where this could fail know that this would fail? So this would be everyone working on the sort of the low-level stuff where you could be handling chunks that exceed 2 gigs.
But no, well, the low-level stuff is actually already protected by this because we specified it's LC4, because otherwise you run over this input buffer limit of 2 gigabytes.
Yeah, you know, this is exactly my point. You know, so having Blosk as your default compressor for the higher level stuff is fine, because the chance of you making a 2 gigabyte chunk is quite difficult. But if you're dealing with chunks of, you know, records or below, you're not guaranteed for this, and I'm not entirely sure who all works down at this level, and so I see this as a cause for potential hard to trace crashes for the I guess not uninitiated, the uninformed, those that don't know the limitations of Blosk.
Point that if you do get that crash, it doesn't give a very nice error. Probably get some integer wraparound, or I forget what it is. But the alternative of putting LZ4 here would mean that for all of the high-level plugins, unless you specify that and make it part of one of the options that you always have to set and not forget, otherwise you use the different compressor, you use LZ4, which is, you know, quite a bit slower and less size efficient than Blosk. So I'd really like to have a compression that works for both. Blosk 2 might do that, but it's not really out yet. So I think for the moment, this is a reasonable compromise, that you have Blosk, but all of the low-level plugins have a different one. yeah, but you're right. It is an issue that everybody who works on these plugins that don't get rejunked, these really low level ones, so records and raw records, anything that has records in the name, needs to be aware of that. That if they start messing around, if they forget here in the where's it, tools processing here, right? So if you would have put this to BLOSK, that will usually work, except one day when it won't, and then you'll have a very unpleasant day.
I mean, couldn't that be a simple check in the saver class?
Okay.
So just check the file size and above 2 gigs, and you decided to BLASK, you could just raise an error or change it automatically.
Yeah, that's great. And you have a much more informative error message, and then it'll just say, hey, maybe you shouldn't have made this plugin BLOSK, let's change it. Unfortunately, we save the compressor along with every data type, so it's fine to change that every week. Yeah, that's a good idea.
I think so.
Wait, so if I suggested it, that means I now have to go and write a.
Oh, definitely not. If you don't, I mean, but I mean.
I'll make a pull request. Yeah.
That's very, very kind of you. You'll see. It's, but yeah, it's these things. You suggest something, and somebody else thinks it's important, and they can make the pull request. Of course.
So Daryl has to make the pull request.
No, that's between you two to negotiate. You can play a game of chicken. Who cares more about this error? But if you make the pull request, you'll see then you get the credit in the commit history. So there's a bit of an incentive.
Yeah, I guess the question for that would be: do we have it throw how actually do we handle this? Do we have it throw an error message, or do we have it automatically switch to a compressor that would work? I think just throwing an error message is probably smarter, because having it switch compression algorithms dynamically, it seems like a good idea until you actually think about what that would mean further down the line.
Maybe a warning?
Yeah, I think you might be onto something here. Like right now, we store only one compression algorithm for the entire data type, so you cannot switch compression algorithms file by file, but you could do that. You just have it in the chunk metadata and say, hey, this chunk was compressed by this compressor. Then you could use BLOSK everywhere, even in the low-level plugins, until a chunk comes along that's too large, and then we compress it differently. Only problem is you first have to compress it to find out what the size is. So,
not strictly. So at least in the C drivers, they have functions where you tell it, well, so I mean, if the uncompressed size is 2 gigs, so if the uncompressed size is at least 2 gigs, then you're not guaranteed that the compressed size is less than 2 gigs. So you could do the split there. If the uncompressed size is 2 gigs, then you switch to LZ4. Otherwise, you use BLOSK.
Yeah, no, it's a good idea. I think certainly feasible. Slightly more complicated, but it would allow us to use BLOSK everywhere, which speeds things up and makes them more compact. So it could save us thousands of dollars, of which you will unfortunately see nothing if you make a pull request. But yeah.
And if we did figure out how to make that work, we could also then have the compressor option. You could just have auto, unless you specifically wanted it to be LZ4 for strange reasons.
Yeah.
You just have it automatically pick compression.
So maybe Joran, but didn't you have a master student? I forget his name who tried to work.
Yeah, Frederick.
Frederick, that was it.
Yeah, so he was working on this, but he mostly actually just confirmed what I'm linking in the chat now, which is what you showed before, which is that ZSTD is maybe the to-go-to compressor. That was actually one question I'm wondering, why are we using BLOSK rather than ZSTD? Probably it's in this. So I'm talking about not what I'm writing, but what you were writing in this pull request. Yeah, this one.
So this here, yeah. Yeah, so let's look. So ZSTD gives you smaller file sizes. but it's slightly slower to read, and also slightly slower to save. So I guess it was a speed decision. And I also don't know how well it performs on large chunks. I haven't tested that. But if that works, then yeah, sure. Let's not use LZ4. Let's use ZSTD. Then if the speed isn't the big issue. As long as we don't use zlib. That's what we used in PAX. Right, here you see why BLOSK is nice, that if you have some reduced algorithm with lots of, some reduced data type with lots of zeros, it's actually faster to compress it than to just save it raw, because you have less bytes to save. But anyway. Yeah, good point. Okay, so this auto compressor would, if it's optimal, always default to ZSTD, is what you're saying.
If I recall correctly, that is indeed what he was advising.
Okay, that suggests something. Yeah. Okay. Any more questions on the plugins, or I suppose other things, since we're anyway going off in tangents, so that's great.
I guess we touched on this briefly. So when it's re-chunking, we have this lovely hard-coded 100 megabytes chunk size. Is it, so 100 megabytes is, relatively small. So I could see kind of two things. One, so we could have this as an option, something in the, I guess this would be like some parameter that you would set when you make this plugin, desired chunk size equals something, and then it throws a warning if, someone says they want 1 megabyte chunks. Or maybe we have it so it automatically emails their institute and home location to computing group. So 100, still 100 megabyte chunks seem quite small. I'm just wondering if we could figure out a better number using this chart, to figure out, where's the break-even point between computing coming around and kneecapping us and making sure that we can actually pull data from disk fast enough.
Yeah. Yeah, there's also the consideration of waveform watching that, or in general data inspection. I want to inspect some data around some event, and I need to download some file from Lukio, and I don't want to download 5 gigabytes because that's going to take a while, especially if it comes from some grid site deep in the Alps or something. So that's what motivated me, since that's the part I at some point did a single month on. So that's why I kept it rather small. So yeah, for me it was like set it at the smallest size, that they indeed will not come and do bad things to me. But certainly we could make it larger to make their life a little bit easier and waveform watchers' life a little bit harder. Yeah. And making options, of course, always nice. You have to pass it through everything, but yeah.
Yeah, maybe this is something that we should bring up at the tools meeting on Wednesday or Thursday.
Yeah.
Is there a minimum file size, or is like what size files would they be happier working with? Given that we have this compromise where computing would be happier if probably it's just single files.
Yeah.
Whereas that does make the analysis a little bit more difficult.
Also, for waveform watching, you wouldn't necessarily per se need all the plugins.
Yes.
You would need some. So, but indeed, if you make this a per plugin dependent setting, you can have both.
Yeah, so you could look at which plugins do you most often need for waveform watching and make their chunk size relatively small. But the ones you most often need are like peaks, which it's probably anyway kept on midway. So, but yeah, if you want to go to the per PNT data, then you got 2 records and raw records, which won't be on midway.
Yeah, but records and raw records are, DAQ chunked, and so, I mean, you're downloading this 5.5 seconds of data. It doesn't matter if it's 5.5 seconds of data where there was very, very little happening, or if it's 5.5 seconds with a neutron generator running at full ball.
You're right.
You're getting that 5.5 seconds.
Good point. So actually, waveform watching doesn't even really come into it. This downloading from Rukio it comes into another consideration, like what should the DAQ chunk like be, but not into this one.
This is a question that I think. How did we end up with the 5 and the 5 second chunks and half-second overlaps? I'm not sure exactly where those numbers came, but the default number in Redux used to be 20-second chunks.
Yeah.
But I mean, these are the numbers passed down on tablets of stone.
Yeah, there is one more consideration, like the memory usage of Strax. And Strax always reads a whole chunk. So if you make your chunk too large, then the memory requirement will be very large in the event builders. I think that was the limiting factor for this time.
I guess probably if we change the chunk size significantly, then your one's going to have to re-benchmark the multiprocessing stuff. I'm sure it'd be very happy to do that.
Yeah, if you buy him the extra RAM that's needed for stuff, I'm sure there can be some arrangement. Nah,
it's just one white Python notebook and no DAQ for a while.
Oh, okay.
No event builders. The DAQ won't be gone.
True.
But I guess optimal chunk sizes is probably something we'd want to talk with the computing group about, like what exactly they would want, and then what we can kind of deal with. Because I think peaks is the plan is to store peaks long term on DALI.
If we can, yeah, or at least OSG close by, yeah.
At least in the original plan that we've been running with the computing group, peaks lives on DALI, and then records lives on OSG somewhere.
Mm-hmm.
And then raw records is probably on tape.
Yeah.
So assuming that we manage to hold on to this, which I think right now there's some questions about disk space because we're storing, 2 months worth of records and raw records on Midway, on DALI. But if peaks, which is I guess kind of the largest locally stored stuff, we can probably earn some brownie points with computing by increasing the chunk sizes.
Let's see, we got just over 5 minutes left. So any more question on the plugins, or see that did cover not forgetting some important piece, right? Yeah, plugins is on the reading. Otherwise, I'll give you a short preview of what's coming next week, though you've had several already on what's coming the next few. All right, so next week we're going to look into the data flow. So inside the plugin, there is some logic which Yossi already alluded to. When you're combining several chunks, for example, you got a chunk of records and you got a chunk of peaks, but to compute, you need to pass perfectly aligned things, so chunks that correspond to the same times. So how do you deal with that splitting issue? You've seen the raw functions this week, so how you split or concatenate or merge a chunk, and this is where you see them in action. We'll also look at the getIter method, which is inside the context, just seeing how it's what sort of operations it's doing with the final data that comes out. And we'll look at, for the first time, into the processor class. And we're not going to look yet at how that's set up, but that's just the general thing coordinating the data flow. So you'll really be following journey of a packet of data from its place in the plugin where it's made. Then it passes through some multiprocessing stuff related to mailbox we get to later, but then it arrives on the processor in the context.py, and then it'll go to the user. So after this, you will have seen all but some very small piece of the data flow in Strax. So that's the idea. So that's all, at least from my side for today. Thanks for bringing all your questions. Appreciate it that we could have a good discussion, even though my preparation was woefully lacking this week. Hopefully next week we can do the same thing, at least with regard to your questions, and then maybe also with a short intro from my side. And so we can progress further in our journey towards the end of Straxferno. Right, so thanks everybody. See you next week then.
Thanks, bye.
Ciao.
Bye-bye.
Ciao, ciao.